we are going to let f of x be equal to 3x cubed plus 8x squared minus 20x minus 16. Now I'm going to say f of x divided by x minus 2 is equal to f of 2, which is equal to 0. All right? I just writing down the information that I have. What I'm going to do now, x minus 2 divided by, well, the polynomial divided by x minus 2, which is 3x cubed plus 8x squared minus 20x minus 16. And I hope you all remember how to long divide. When we long divide, first inside divided by first outside, I will get 3x squared. Then multiply 3x cubed minus 6x squared. And I take away. When I take away, I get 8 plus 6 going to be 14x squared. And I bring down everything else. Minus 20x minus 16. So I bring down these things here and I bring it down. I repeat again. I'll get plus 14x multiplied. I'll get 14x squared minus 28x. Take away again. I'll get minus 20 plus 28, which is going to give me 8x. And I'll bring down the minus 16. I'll get plus 8. And I'm going to get 8x minus 16, resulting in a remainder of 0. So all's well and fine. Now I can say, therefore, f of x. Let me work in such a way. I will show you how to write up all the work on all the papers just now, right? It could make a big difference. Now you all are allowed to ask for paper in an exam, right? Don't afraid to ask for paper in the exam. Now I can say, therefore, f of x is x minus 2 multiplied by the quadratic. 3x squared plus 14x plus 8. And I know some of you all have the skill set to factorize this in one line. If you don't have the skill set to factorize this in one line, go ahead and go through a factorization process. All right? Come in your working column. And you're going to say 3x squared plus 14x plus 8. I'm going to have 8 3s are 24. Which two numbers when I multiply could give me 24 and add to give me 14 by 12 and 2? 3x squared plus 12x plus 2x plus 8. And I will get 3x into x plus 4 plus 2 into x plus 4, resulting in x plus 4 into 3x plus 2. So f of x is equal to x minus 2 into x plus 4 into 3x plus 2. But the question never tell me to factorize the polynomial. The question asked me determine the other linear factors. So my last line should reflect my answer. Therefore, the other linear factors are x plus 4 and 3x plus 2. All right, Manda? Good. Now we have the hence. There's part 1, part 2. Label part 1. Part 2. Hence, simplify the multiplication. Well, that polynomial now becomes x minus 2 into x plus 4 into 3x plus 2 divided by x squared minus 4 multiplied by x plus 2 over x plus 4. All right, no scene. I've seen this x plus 4 canceling with this x plus 4. Have you seen that? But before I even do that, I've seen something else. I've seen the underneath is a difference of 2 squares. So let me line that up now. Again, I'm jumping out of my working column, and I go down and say, hey, here was the scene. X squared minus 4 is actually x squared minus 2 squared, which is a difference of 2 squares, which is going to be x minus 2 into x plus 2. Cool? So now I go have x minus 2, x plus 4, 3x plus 2 over x minus 2 into x plus 2 multiplied by x plus 2 over x minus 4. Now I could go x plus 4, sorry. Now I could go and cancel my life out. X plus 2, x plus 2, x plus 4, x plus 4, x minus 2, x minus 2 to give me my final answer to be 3x plus 2. All cool with that? Cool. All right, fellas, give me 2 minutes, right? All right. The equation, so by so, has roots alpha and beta where k is a whole number. And this was the error in this particular question. They say k is a whole number, and we're going to see it coming to play in part 2. Determine expressions for alpha plus beta and alpha beta. No scene. So there'll be a hero, k x squared plus x minus 15 is equal to 10. Rearrange it. K x squared plus x minus 15 minus 10 is equal to 0. And kx squared plus x minus 25 is equal to 0. A is k, b is 1, and c is minus 25. Since alpha and beta are the roots, we know that the sum of the roots for any quadratic is minus b over a, which is minus 1 over k. And alpha beta is equal to c over a, which is minus 25 over k. Cool. Easy to marks. This is B part 1. Given that alpha squared plus beta squared is 61 over 4, use expressions in B part 1 to determine the value of k. All right, so we know that how alpha squared plus beta squared is actually alpha plus beta squared minus 2 alpha beta. I know what alpha plus beta squared is. So I'm going to let alpha plus beta squared minus 2 alpha beta be equal to 61 over 4. Alpha plus beta squared is minus 1 on k. So I'm going to get minus 1 over k all squared. Take away 2 into minus 25 over k is equal to 61 over 4. I'm going to get 1 over k squared. Come on. 1 over, good, k squared plus 50 over k minus 61 over 4 is equal to 0. Are you cool with that so far? Everybody comfortable with that so far? Now I will multiply everything by k squared. So I can multiply everything by k squared to get 1 plus 50k, take away 61 over 4. Let me multiply everything by 4k squared now to get rid of the 4 in the denominator as well. 4k squared. I'll get 4 plus 50 by 4 is 200k minus 61k squared is equal to 0. Send everything on the next side. I'm going to get 61k squared minus 200k minus 4 is equal to 0. Now, I don't know if this is factorizable. Don't know. Let me check and see. If it is, be glad. 61, 200, and 4. Not factorizable, so we have to go into our quadratic formula. Okay? So A is 61, B is minus 200, and C is minus 4. In this case, K is a variable, so K is equal to minus B plus or minus the square root of B squared minus 4AC all over 2A, which is equal to minus 200 plus or minus the square root of B squared minus 200 squared minus 4AC all over 2A. K is equal to 200 plus or minus, and I'm going to work out what this number is, right? I'm going to actually work out what it is. So I get 200 squared minus 4 multiplied by 61 multiplied by minus 4. And the square root of that number is 202.23. 0.43, sorry. All over 61 by 2 is 122. So K is equal to 200 plus 202.43 over 122. Or K is equal to 200 minus 202.43 over 122, which is equal to 202.43 plus 200 divided by 122, 3.3, or 200 take away 202.43 divided by 122, negative 0.02. Cool. Now, they did say K is a whole number, which is why this question has an error. K is decimals. Everybody okay with that? All right, so looking good for 4 marks. I mean, you would get marks. Cool. Minus 15 minus 10, kx squared plus x. Good. Nice, so we're good to go. For the quadratic function g of x, determine the exact value of the minimum point and the range using the method of completing the square or otherwise. Okay, now, this is a nice question, right? Real nice. Maximum point, easy. If g of x is equal to minus 5x squared minus 4x plus 2, I want to say that a maximum point, actually, I'll get the first derivative, which is g dash x, going to be minus 10x minus 4. All are comfortable with that terminology, right? I would believe I showed you all that. Instead of having y and, when I differentiate, I get dy dx. If I have a function, f of x, and I differentiate, it's f dash x. If I differentiate again, it will be f double dash x. and so on. Cool? So just keep that in mind. Write that down if you didn't know. We say at a maximum point, g dash x is equal to 0. So we will let minus 10x minus 4 equals to 0. Minus 10x is 4. And x is equal to 4 over minus 10, which is minus 2 over 5. G of minus 2 over 5 is equal to minus 5 into minus 2/5 squared minus 4 into minus 2/5 plus 2. And this is the beauty of having a function as an equation. I don't have to say when x is negative 2.5, y is equal to. I could jump straight into my function terminology and write down g of negative 2.5 to get minus 5 into minus 2 over 5 minus 2/5 squared minus 4 into minus 2/5 plus 2. I get in 14 over 5. So I can say, therefore, the maximum point occurs at minus 2/5, comma, 14 over 5. All right, Manda? All right, now, you see how the question wrote up itself? Determine the exact value of the maximum point and the range using the method of completing the square. So we could have used completing the square if we wanted to, but the fact that they say or otherwise, we could have go ahead and differentiate. Are you cool with that? If they didn't say or otherwise, I would have no choice but to use completion of the square. All right? Now, the word range. The range of a function is its where it existing on the y-axis. So if I draw this graph, right? This graph going to look like this, correct? This point here is going to be minus 2/5, comma, 14 over 5. All cool with that? And this graph continues to go down and down and down and down until negative infinity. All agree with Manda? So this graph actually existing from this point and underneath. That's where the graph is. Yeah? Now, range is locked to the y-axis. And I believe I did this with earlier. That would have been in... I'll do that with earlier. I didn't do that with earlier. I didn't talk about range and domain with earlier. I remember. Let's talk about it now. To talk about it, let's go into GeoGebra. Let me start off easy, right? And I want all the input. Please, fellas, I want all the input. Whether all the right or all the thing all the wrong, I want all the input. I'm going to draw a straight line here. Everybody comfortable is a straight line here, right? Yeah? So, if I could pick a x value and get a y value for any line or any curve or any graph, the graph exists. For example, when x is 1, can I get a y value? Yes or no?
Yes, sir.
The graph exists. When x is negative 6, can I get a y value?
Yes, sir.
The graph exists. So the graph exists at 1, the graph exists at minus 6. So with that being said, can you all tell me all which part this graph does exist? Which part does the graph exist? I know it exists at 0 because I could get a y value. I know it exists at 1, 2, 3, 4, 5, 6, and so on. So if I could summarize which part the graph exists, what will you tell me? I'll see.
It exists infinitely.
I mean, I wouldn't use that word infinitely. Use a different word now. Use a non-mathematical word. Where does the graph exist? What a time for his camera to stick. My goodness.
So I can answer.
Yeah, Connor, go ahead now. Try.
See, I don't know.
I
I'll,
got you.
I'll
Right.
be back. Yeah.
My boss internet out there.
Mm-hmm. Tell me.
But I said the line encryption it exists infinitely and everywhere.
I do like the word infinitely. I like the second word you use.
Everywhere?
Everywhere. Yeah?
Mhm.
It exists in everywhere for every value of x, correct?
Mhm.
Yeah? So tell me if this is making sense. This straight line exists for all real numbers. Or the straight line exists from negative infinity to positive infinity on the x-axis. Everybody comfortable with that? You see that? That's called a domain. A domain is locked to the x-axis. However, a range is locked to the y-axis. So can you all tell me the same thing here? For every y, we go how to go across, right? Instead of going up, down. For every y, can you all get an x? When
Yes,
y
sir.
is 1, and I could go across and get x.
Yes, sir.
When y is 1200, and I sure I could go across and get x.
Yes, sir.
So the range of this function is also between negative infinity and infinity. Yeah? Good. Now, if I have a quadratic, I could put in the information here. All right, so let me see. Let me talk about domain, right? Again, domain is locked to the x-axis. Cool? All right. When x is 0, do I have a y? When x is 1, do I have a y? When x is a million, do I have a y? When x is negative 6,000, do I have a y? Because the graphic continues to grow up and out. Yeah? So I can also say the domain of this graph is between negative infinity and infinity. Correct? Well, cool with that. Range now. Does this graph exist everywhere on the y-axis? It doesn't. Definitely doesn't. Which part does the graph not exist? I could see somewhere underneath there. Yeah? Somewhere underneath the minimum point. Correct? But how I'm going to write that? What number will that be? I have two numbers to pick from. I have negative 2.5 and negative 3.5. Which number will I pick to represent my range? Nico, you want to give it a try? Which one of those numbers will I use to represent the range? I will give you a hint. The range is locked to the y-axis. Go ahead.
Negative 3.25.
Why?
Because the graph doesn't exist below that point
Very good. The graph
on the
doesn't
y-axis.
exist. Very good. Below that point. Yeah? So if I draw this line, y is equal to negative 3.25. All you see that line there, right? Underneath that line, the graph do exist. All agree with that? So I could write this down two ways. I can say that how the range of this graph is y is greater than or equal to negative 3.25. Yeah? The range is which part the graph exists in. Cool? So the graph exists in above negative 3.25, inclusive of negative 3.25, because that is a value of the minimum point. Are you seeing that? So this graph exists in everywhere above that straight line. The straight horizontal line. Are you cool with that? That's one way to write it down. I could also say that how y is between negative 3.25 and infinity. Yeah? Positive infinity. Are you cool with that? Granted that the range is locked to the y-axis, I have in my possession here the coordinates of a maximum point of a graph. Now, a maximum graph looks like this. All right, Manda? This point here is going to be my negative 2/5, which is our x coordinate, and 14/5, which is our y coordinate. If I do the same thing, this straight line going to be my 14/5. All agree with Manda? So this graph exists everywhere below. Agreed? Now, since the range is locked to the y-axis, this question do have a y. It have a g of x. So this range will be locked to the g of x axis. Cool? If I had y is equal to, this could be my y and this could be my x. But I don't have y is equal to, I have g of x is equal to. So this range is locked to the g of x axis. And my range is going to be g of x is less than or equal to 14/5. All right, Manda? Again, I'll draw the graph. This is the point minus 2/5, 14/5. This straight line represents 14/5. And the graph existing everywhere below, inclusive of 14/5. Yeah? All comfortable with that? Lovely. All right. Write this as a single term. Two-part A. Log 2 log of x to base 3 plus 2 take away log of y to base 3. I go have a recall line here to recall whichever logs I'm using. I seen a minus logs, I seen powers logs, so I'll recall log of m to base b plus log of n to base b. The laws work both ways. This is log of mn to base b. I also know that how log of m to base b minus log of n to base b works both ways. It's log of m over n to base b. I also know that how log of a to the power c to base b works both ways. It's c log of A to base B. And finally, I foresee in all of this, right? If you don't foresee it, you can put a recall whenever you're using a law of logs. Log of A to base A is equal to 1. So, my question now turns into log of x squared to base 3 plus 2 log 3 to base 3 minus log y to base 3. I'll get log x squared to base 3 plus log of 3 squared to base 3 take away log of y to base 3. This now becomes log of x squared multiplied by 3 squared divided by y to base 3. Simplifying it down to be log of 9x squared over y to base 3. Smooth. Wanna cool it up? Right, we use a lot of laws there. We use 4 laws there. All right, so B part 1. By using logs, express the relationships. The relationship V is equal to 7 multiplied by 5 to the power t in linear form. V is equal to 7 multiplied by 5 to the power t in linear form. So what I want to make it look like y is equal, a variable is equal to a constant by a variable plus another constant. I believe we would have done this. Where is logs? Wait. We didn't do logs? We did logs. Oh, yeah. Sorry. Solving exponential equations. We did logs. Right? Smart substitution. Okay, good. We did logs. I did not do conversion to linear form with you guys, right? Okay, no scene. Conversion to linear form is one of those questions that it comes, but not really often, and it's not difficult. So, linear means line. Oh, look at that great Monda. Line is y is equal to mx plus c. Or more importantly, variables and constants are in those positions. So the equation of a line is a variable is equal to a constant multiplied by a variable plus another constant. Are you all seeing that? Nice. Now, what I'm going to do, I'll introduce logs, right? You have to introduce logs to get rid of the exponent on top. I'll take ln on both sides. Well, you know I like ln. ln v is equal to ln 7 multiplied by 5 to the power of t. All cool with that so far? Now, I'll recall one of the laws of logs. I'm going to split up the product as the sum of two individual logs. All cool with that? So I'm going to get ln v is ln 7 plus ln 5 to the power t. And I'll also recall the law that brings the power down. So now I'll get ln v is ln 7 plus t ln 5. I could write this down like the equation of a straight line now. A variable is equal to a constant, which is ln 5, multiplied by a variable plus another constant. All see that? And I could say is of the form, you could say common y is equal to mx plus c. No scene with that. Right? No scene with that. Yeah? Where, let me foreshadow in the next piece, where m is a gradient, which is ln 5, and c is the y-intercept, which is ln 7. Part 2. Hence, state the value of the gradient of the line which represents the relationship in B. So we say gradient. We already do it already. Gradient is equal to ln 5. All cool with that?
Excuse me.
Yeah,
I'll have to go just now.
no problem. Just watch the recording for the rest of the solutions, right? A. Rationalization. Easy thing. I'll have 1 plus root 2. And I'll show you all how to cheat for these to check, make sure your answer correct, right? Anybody knows how to check if your answer correct for this? Nobody? Nah, man. All right, so
plug it in and take calculator.
explain some more.
And like, yeah, just plug it in.
You give me no kind of substance there, you know? Because them fellas go plug it in the calculator and be like, well, what Mark talking about? So what do you mean, Mark? What do you mean when I say plug it into your calculator?
Or like, if you have a Casio, you could get into you could get into that third form.
Right, but not everybody has Casio, you know?
Yeah, that's the thing.
Right, but you could still double check your work. I'll show you afterwards, right? Let me go and rationalize. This is equal to, I'm multiplying everything by 1. I'll get 3 plus root 2. Then multiply everything by root 2 plus 3 root 2 plus 2. All over. This is a difference of 2 squares. I'll get 3 squared, which is 9. Take away root 2 squared, which is 2. This is 3 and 2 is 5. Plus 4 root 2. Over 9 minus 2 is 7. Cool? We rationalize the denominator there. Now, how I checking this to see if this is correct? Rationalization, all it does is it changes how the question looks or how the expression looks. Doesn't change the value of it. I wonder, boy, what is 1 plus root 2 divided by 3 take away root 2? That is 1.522407775. Yeah? I wonder, what is 5 plus 4 root 2 and 7? 5 plus 4 root 2 equals divided by 7. It's the same thing. Yeah? That's how we could double check our work. Real easy. All right, evaluate. Oh, good. Oh, good. Yeah. The sum where I goes to 10, from 10 to 0, that is 0, sorry. I goes from 0 to 4 of 5 to the power I minus 2. Now, how does this is called sigma notation. Sigma means summation. So the underneath number tells me where I am starting with. The top number tells me where I am ending at. So I will take values 0, 1, 2, 3, and 4, and I have to add up those values. So this is equal to 5 to the power of 0 minus 2 plus 5 to the power of 1 minus 2 plus 5 to the power of 2 minus 2 plus 5 to the power of 3 minus 2 plus 5 to the power of 4 minus 2. The top number tells us where to stop. This is equal to 5 to the power minus 2 plus 5 to the power minus 1 plus 5 to the power 0 plus 5 to the power of 1 plus 5 to the power of 2. All right, Manda. Plug it in a calculator, no? Nothing wrong with that. Nobody ever vex at all, yeah? 5 to the power minus 2. Let's put each one in brackets. 5 to the power minus 2 plus 5 to the power minus 1 plus 5 to the power 0 plus 5 to the power 1 plus 5 to the power 2 equals 3 to the 1.24, or yeah, let me go with 31.24 now. That's looking a little nicer. Yeah. Usually, I am very against decimals, but because this decimal is exact, I have no problem writing it down. All right. If all I wanted to write down a fraction equivalent, no scene. However, if this was irrational, meaning it full up my whole calculator, brother man, I write it down what the fraction is. Me approximating. Cool? Nice. Determine whether the sequence is divergent or convergent and justify your response. Now, this is a APs and GPs question. Cool? So I can safely say this. If the sum to infinity exists, the series is convergent. Simple as it seems here. If the sum to infinity exists, a series is convergent. Cool? This is going to be a geometric progression. Yeah? So I'm going to say part E. A is 1 and R is equal to minus 2/3 divided by 1, which is minus 2/3. So that was easy. A and R. The sum to infinity is equal to A over 1 minus R. This is equal to 1 over 1 minus 2/3, which is equal to 1 over 1 and 2/3. Check it now. 1 divided by 1 and 2/3. I get 3/5. Cool with that. Yeah? Now we see, since the sum to infinity exists, this sequence is convergent. Yeah? Easy, right? Thinking about something here, right? All right, cool. Determine the points of intersection of the circle and the line that. Okay, so first things first, 3 part A. Any questions so far? All good so far? 3 part A. Let x squared plus y squared minus 4x plus 6y plus 8 equals 0. Let this be 1. And let y is equal to x minus 6. Let this be 2. Substitute 2 into 1. I'll get x squared plus y squared minus 4x plus 6y plus 8 is equal to 0. X squared plus x squared minus 12x plus 36 minus 4x plus 6x minus 36 plus 8 is equal to 0. 2x squared minus 12 minus 4 is minus 16. Minus 16 plus 6 is minus 10x. And plus 36 minus 36 is 0 plus 8. Because it's an equation, I could divide everything by 2. X squared minus 5x plus 4 is equal to 0. And there's look up thing to factorize, right? This is going to be x take away 4 into x take away 1 is equal to 0. I'm going to get x is equal to 4, and because they want points of intersection, x is equal to 1. Cool? I'll let more not so far. All right. Now they say determine the points of intersection. Now we say when x is 4, y is equal to 4 minus 6, which is equal to minus 2. And when x is 1, y is equal to 1 minus 6, which is equal to minus 5. Therefore, points of intersection are going to be when x is 4, y becomes minus 2. And when x is 1, y would have been minus 5. Easy 5 marks. Yeah? Given that the coordinates of 3 points, the coordinates of the points, A and B are that and that respectively, state the position vectors corresponding to the points A and B in the form x plus I, xi plus yj. So if I have a point somewhere in space, a position vector goes from the origin to that point. So very, very easy. This is B part 1. The position vector OA, it's just going to be the x coordinate of A, I, and then the y coordinate of A, G. We're looking confused. Okay, good. Then OB go be the position vector for B, go be the x coordinate plus 1G, or just G alone. Part 2. Determine AB. Now, two things we could do. We could draw it and count, or we could calculate it. Yeah? AB is equal to AO plus OB, which is equal to minus OA plus OB, which is equal to minus 7i minus 3j plus OB, 2i plus j. Add the I components together, minus 7i plus 2i. Add the j components together, I'll get plus 3j in the beginning, plus j. Minus 7 and 2 is minus 5i, plus 4j. Part 3. Determine the scalar product OA dotted with OB. Now, they should have put an arrows over these things. OA dotted with OB. They should have put arrows. So, OA dotted with OB, I can change from IJ format to vector format. And that's the easiest way to dot product. 7 minus 3 dotted with 2, 1. Multiply the tops, which is 14, plus multiply the belows, which is minus 3, and I get 11. Yeah, easy vectors question. Real easy vectors question. 5 marks for all others here. And then 5 marks for all others here. Nice small thing. Using the letters P, Q, or R, find an expression for each of the following trigonometric ratios. What kind of maths question is this, boy? C part 1. Sine theta is opposite over hypotenuse. The opposite is P. The hypotenuse is Q. Cos theta is adjacent over hypotenuse. The adjacent is R. The hypotenuse is Q. Use your answers in C part 1. Determine the value of sine squared theta plus cos squared theta. Recall sine squared theta is sine theta squared. Now, we could cheat, right? But we wouldn't. Part 2. Sine squared theta plus cos squared theta. Going on B. P over Q squared plus R over Q squared. This is going to be P squared over Q squared plus R squared over Q squared, which is going to be P squared plus R squared over Q squared. And if I don't know anything from maths, sine squared theta plus cos squared theta is 1. That's all the identities for maths. Cool? So I'll recall that based on I wouldn't recall this, right? I'll also say, in addition to C part 1, right? I'll also say that the hypotenuse squared is the opposite squared plus the adjacent squared. So I'll get Q squared is equal to P squared plus R squared. I have P squared plus R squared on the numerator. So this is actually Q squared over Q squared, which is actually 1. Yeah? Now, they didn't say to go so far because they just said using your answers in C part 1. So if that is the case, you could have stopped at P squared plus R squared on Q squared. That is sine squared theta plus cos squared theta. Yeah? Take it a step further. Distinction. I read list. Cool? A. Prove the identity. Tan A plus 1 on tan A is 1 over sine A cos A. No scene. So required to prove that tan A plus 1 over tan A is equal to 1 over sine A cos A. This is an easy proof. Proof taking the left-hand side, tan A plus 1 over tan A. Recall tan A is sine A over cos A. So I'm going to get sine A over cos A plus 1 over sine A over cos A, which now becomes sine A over cos A multiplied by cos A over sine A. I want to get 1 over sine A cos A. Now, cancel, cancel. I get 1. I don't want to do that. Damn. All right. So I already have the denominator. Cos A sine A, right? I already had the denominator. I want to make the numerator look like 1. Oh, shucks. Why did I multiply 4? It's plus. Yeah, it's plus. My bad. All right, good. That makes a lot more sense. All right, LCM down the place. I'll get sine squared A plus cos squared A over sine A cos A. Well, cos A sine A. I'll go back up to my recall line and I'll recall sine squared theta sine squared A plus cos squared A is equal to 1. So I'll end up with 1 over, and I'll put the sine A first because multiplication is commutative. 1 over sine A cos A, which is equal to the right-hand side, QED. Yeah? Number 4 already, boy? Number 4, number 5, and number 6 are nice, isn't? Jeez, I need it. Right. Use the definition of the derivative as a limit to find f dash x for the function. No. This was a controversial question because the concept of limits is not taught readily at a Form 5 at maths level. Okay? It's not taught at the advanced level at all. I'm not going to dive into it. I'm going to do the solutions for it. But basically what they're asking us for, they're asking us to differentiate x squared minus 3. When I differentiate that, I get 2x. Agreed? All right. Now I'm going to show you what the question wanted us to do. The question wanted us to calculate this. The limit as h tends to 0 of f of x plus h minus f of x all over h. So let's consider f of x plus h minus f of x all over h. This is equal to f of x plus h going to be x plus h squared minus 3. Take away x squared minus 3 all over h. This is equal to x squared plus 2xh plus h squared minus 3 minus 3 minus x squared plus 3 all over h. Right, we're taking a page out of functions here, right, fellas? X squared and the x squared cancels. Minus 3 and the 3 cancels. I remain with 2xh plus h squared all over h. Cancel one of the h. Cancel the h with the denominator with each h on top. I'll get 2x plus h. So the limit as h tends to 0 of f of x plus h minus f of x all over h is equal to the limit as h tends to 0 of 2x plus h, and from here is a substitution game. Plug in h to be 0, 2x plus 0, which is 2x. Now this concept, it's very easy to understand and follow. whatever the function is, if they're asking something like this again, right? Whatever the function is, you see this fella here? How to do? How to do? F of x plus h minus f of x. You have to calculate. When you do this, or when you take away any term that doesn't have h in it, there's always cancel. If you realize this don't have h in it, and this minused out, then this didn't have h in it, and well, it disappeared. The terms with h survives. 2xh and the h squared are the only two terms that survive. When we divide by h, this h is cancelled with each of the h's on top. From here, we write this definition, then this, and then plug in h is 0. It's not readily on the syllabus. On the fence. All right, on the fence. When we're doing all the solutions, if we bounce up another question that has easy differentiation, I will do it from first. This is called first principles. I will do it from first principles. Hence, determine the value of f double dash of 5. So, let's say hence, right? I calculated the first derivative. The second derivative, I can say that how f dash x is equal to 2x. F double dash x is equal to 2. F double dash of 5 will also be 2. Because think about it. This is 2x to the power of 0. This is 2 into 5 to the power of 0, which is 2 into 1, which is 2. Thelma, will you go to that? Well, at least part 2. This was a kind of out of timing calculus question to bring in this year. It was out of timing. Right, given that y is equal to sin x on cos x, show that dy dx is 1 on cos squared x. No scene. So we can say that how y is of the form u over v, where u is sin x, du dx is cos x, and v is equal to cos x, dv dx is minus sin x. Quotient rule up the place, dy dx is equal to v du dx minus u dv dx all over v squared. Brother man, this is my quotient rule. This is equal to v du dx minus u dv dx all over v squared. The top becomes cos squared x plus sin squared x all over cos squared x. And I go ahead to recall an identity here. This is dy dx still. I'll recall that cos squared x plus sin squared x is 1. So dy dx is 1 over cos squared x. Yeah? All right. Determine the equation of the gradient. Okay, no scene. The equation of a curve is given by y is equal to that. So part C. Did I label this as part B? I didn't. Part 2. Part 1. A. Part 1. Part D. I just labeling it, right? Nice. Yeah, we was here. So if y is equal to 5x squared minus 7 to the power 4, this is a straightforward chain rule, so we had to show the substitution. Let t be equal to 5x squared minus 7. I'll get dt dx to be 10x. And from here, I'll go to that. Therefore, y becomes t to the power 4. dy dt is 4t cubed. dy dx is dy dt multiplied by dt dx. Good old-fashioned chain rule. dy dt 4t cubed multiplied by dt dx 10x and replace t. I'll get 40x into 5x squared minus 7 all cubed. Wow. Yeah. Now it does look easy when I do the questions, but to really learn and to really have the learning process taking place, all you had to do it and get wrong. Okay? Don't wait for me to do it now. Next week we do in 2023, I'll learn all you know from now. All right? Don't wait for me to do it. The region enclosed between the curve, the x-axis, the y-axis, and the line x is 2 is rotated about the x-axis through an angle of 360. Calculate the volume of the solid of revolution that is formed. Okay. I know rotation through the x-axis. So I'll let v be equal to the integral of pi. If I rotate through the x-axis, it will be pi y squared dx between b and a. So v is equal to the integral. The upper limit is 2. The lower limit will be 0 because this is the y-axis. That y-axis is x is equal to 0. The function is going to be pi into x squared plus 1 squared dx. And there's it. This is all we had to do. Let me expand it out. Pull the pi on top. Pi, the integral between 2 and 0, of x squared squared could be the first term squared, which is going to be x to the power 4, plus multiply the two terms by each other and double it, 2x squared, last term squared, dx. If you want to multiply it out in the working column, no scene. V is equal to pi into x to the power 515 plus 2x cubed on 3 plus x between the limits 2 and 0. V is equal to pi into, substitute 2 as my limit first, 2 to the power 5 over 5 plus 2 into 2 cubed over 3 plus 2. Take away. Substitute the 0, please. 0 to the power 5 over 5 plus 2 into 0 cubed over 3 plus 0. I know it's going to be 0, but please get in the habit of substituting it. And V is equal to pi into, jump on the calculator. The only bracket I'm concerned with is the first one. 2 to the power 5 is what, right? 32. So I got 32 on 5 plus 2 2s are 4 2s are 8. 2s are 16 on 3 plus 2. 206 on 15. Cubic units. Yeah, if you want, you can multiply the pi. There is no scene. Okay? now. All right, a particle moves along a straight line. As a particle moves along a straight line, sorry, its displacement is measured from a fixed point O on the line. At a time t seconds, the acceleration A is given as A is equal to 24t minus 14. Find the expression for the velocity v of the particle given that when t is 1, v is 3 meters per second. All right. Already remember your word? Zva, S-V-A. You remember that, right? Good old-fashioned Zva. So for Zva, I have S-V-A. If I have acceleration and I want velocity, I'll have to integrate. So v is equal to the integral of a with respect to t. So v is equal to the integral of 24t minus 14 with respect to t. V is equal to 24t squared on 2 minus 14t plus c, where c is a constant. Now, they gave us when t is 1, v is 3. So they gave us conditions to calculate c. When t is equal to 1, v is equal to 3. So I'm going to let 3 be equal to, I could simplify this now, 12 into 1 squared minus 14 into 1 plus c. 12 minus 14 is minus 2. When I send it across, it becomes plus 2. 5 is equal to c. Therefore, v is equal to 12t squared minus 14t plus 5. Part 2. Use your answer in B part 1. Using your answer in B part 1, find an expression for displacement of the particle given that when t is equal to 1, s is 10. So it's the sameness yet again. I'll have to integrate and they give us conditions. So s is equal to the integral of v with respect to t. S is equal to the integral of 12t squared minus 14t plus 5 with respect to t. S is equal to 12t cubed over 3 minus 14t squared over 2 plus 5t. I already used c above, so I'll use plus k, and I'll say k is also a constant. They say that when t is 1, s is 10. So I'll let 10 be equal to, and I'll simplify, 3 into 12 is 4, 4 into 1 cubed, take away 7 into 1 squared, plus 5 into 1 plus k. And I can mental this, right? 4 minus 7 is minus 3. Minus 3 plus 5 is 2. When I move the 2 across, it becomes minus 2. 10 take away 2 is 8. Therefore, s is equal to 4t cubed minus 7t squared plus 5t plus 8. Part C, the gradient function of the curve C is given by that. So gradient function means that is dy dx. So I know that our dy dx is equal to 7 minus 2x. If the curve passes through the point 38, find the equation of the curve. So if I integrate both sides, with respect to x, I'll have the integral of dy dx with respect to x is the integral of 7 minus 2x with respect to x. When I integrate a differential, I get back y is equal to 7x minus 2x squared over 2 plus c. Now, I could use c as my constant because this question is completely separate from part B. where C is a constant. Now we can say that how the point 3, 8 is on the curve. This is my y value. This is my x value, which satisfies the equation of the curve. So let 8, which is my y value, 7 into 3, take away, cancel the 2's. My x value will be 3 squared plus c. Again, we can mental this. 8. Well, we go move across now. 8 take away 7 3s are 21 plus 9 is equal to c. 8 plus 9 is 17. 17 minus 21 as well. 17, 18, 19, 20, 21, minus 4. Therefore, y is equal to minus x squared plus 7x minus 4. Easy peasy. If we differentiate this here, we're going to get the 7 minus 2x as a gradient function. And 3, 8 is going to be a point on this curve. So you can double check when x is 3. Check it over here. When x is 3, I'm going to get minus x squared, which is going to be minus 3 squared, which is going to be minus 9. Minus 9 plus 21 minus 4. Let me check it back and see now. Is minus x squared, which is going to be minus 9 plus 7 3s are 21. Take away 4 is 8. So we get back our y coordinate. All right, probability. Oh God. The height of 35 children at a nursery were recorded to the nearest centimeter. The data is shown below. Display the data shown above in a stem and leaf. So as seen here, we have values both in the tens and in the hundreds. So when you're creating your key, create your key and cater for the tens. Cool? Now, when you cater for the tens and you had to put in the hundreds, it could be a little bit complicated to see. So separate the numbers with a comma. So let's go. First, I'm going to write down what my key is. I'm going to say 1/1 is equal to 11. There we go. 1/2 is equal to 12. Cool. All right, Manda. That's good enough for a key. So I had a key here, and I'm not going to start with ones. The lowest number I see in here is looking like in the 60s. Yeah? May have a number in the 50s. When I use a number, I will cross it out. So my key going to start in the 60s. I'm going to have I'm going to have 6, 7, 8, 9, 10. By 11. It have 120 something. You go just by 11 here. So the first one is 61. Have any more 61s? No. I've seen 162, 2 62s. I see no more 62s there. So I have 1, 2 62s. Any more 60s? Yeah, I have a 67. That is it for the 60s, right? Moving into the 70s now. 75. Okay, I seen a 70. I seen a 70. I seen a 71. 70, 71. 75, 76, 74. So 74, 75, 76, 74, 75, 76. 77s. No. I seen a 78 and 2 79s. 78 and 2 79. Right? Oh, look at 65 there. So I seen a 65. So I go rub off the 7, put a 5, and put a comma and a 7. Right? So if I miss something, I could always come back to it, right? Look at next 79 here. Comma 9. I see no more 70s. Let me look at the 80s now. I see in any 80? No. I see in 81, 83, 81, 83.
So now 80.
Have I 80?
Top right.
Top right. Nice. 80. So bring it around. 80, 81, 83. Good. 84. And I see now 86. That looking like it for the 80s. 90s now. 90, 92, 92, 92, 90, 92, 92, 92, 94, 95, 94, 95. I'm going in the hundreds now. I've seen 103, 108, 109, 109, 103, 108, 109, 109, and then 111, 15, 16, 18. 111, 15, 16, 18. All cool with that? All right, double check. 35 children at the nursery. Check and see if you have 35 numbers here. Let me check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33. Jesus Lord. I'm missing 2 numbers. All right, I see the 2 numbers I'm missing. See how important it is? I'm missing a 99. And I'm missing 108. So I'll move this around. I have 108 here. I'll let you know how important it is to check it over, right? Yeah? All right, good. From the stem and leaf, determine the median, lower, and upper. So the median, super easy. I'll show you how to do this already. We canceling first with last, 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 going on the road. Yeah? So there we go. First with last. Got enough pen on this now. Right, first with last, first with last, first with last, first with last, first with last. Actually, what do I want all to do? Now, you all are going to be marked on these things, right? I don't want to disrupt this diagram. Because if you disrupt this diagram, it will look like a cross off some things in the diagram. Yeah? I don't want that to happen to all you. So instead, this is what I want all to do. For the median, that is what? 3 marks. So 1 mark each, right? So the median is the middle value. Kind of goes it. All right? What you can do, and only, this is only for the median. The median is the n plus 1 over the tooth value, which is going to be 35 plus 1 over tooth value, which is going to be 36 over 2. That is what? 18, my 18th value. So I had to count my 18th value. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And my 18th value, Q2, the 18th value is equal to 84. This is Q2. Cool? Is equal to 84. Now they want the lower and the upper quartile. Now here is where I will advise you all to be a little cautious, right? So this here, that's my median. That median now splits up the first half of numbers and the second half of numbers. So this is the first half of numbers here. Well, cool with that? The middle of those numbers is Q1. Cool. So if you want, you could count how much numbers they are over there, or you could ghost the canceling. Use a pencil, cancel with the pencil, and then rub it off afterwards. All right, wake up, Varun. So let me cancel first with last, right? You could do this to cut some corners. In the beginning, cancel 1, 2 with the last two. Then 1, 2 with the last two. Then 1, 2 with the last two. Now you could cancel first with last, right? So if you watch, I cancel 1, 2, 3, 4, 5, 6. 6 of the first set of values, and I cancel 6 at the last set. I go first with last. First with last. I remain with 75. Cool? But you're doing that with a pencil and rubbing it off. Q1 is 75. And you're doing the same thing with the next set. Let me cancel the first 6 again. 1, 2, 3, 4, 5, 6 with the last 6. 1, 2, 3, 4, 5, 6. Now first with last. Oh shucks, I forget the 6. Damn it. Now I forget the 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Cancel first with last. First with last. 103 is Q3. Well, cool with that? Right? And make sure, rub off all your pencil markings that you use to cancel. All right? Make sure and rub it off. All right. At another nearby nursery, the heights of the children of the same age were recorded. The median height was 79 and the interquartile range was 24. Compare the characteristics of the two groups of children at the two nurseries and describe one distinct observation about the distributions. All right. So the median height was 79. So let me have a little summarization of the nurseries. So let me go with nursery 1 and let me go with nursery 2. Nursery 1, which is the first nursery, Q1, Q2, Q3, and the interquartile range is equal to 75, 84, 103. 75, 84, 103. Interquartile range, Q3 minus Q1. Check it out. 103. Take away 75, 28. Nursery 2. Let me see what information they give us for nursery 2. If they give us all of this. If not, that's okay. They say that the median is 79, so Q2 was 79. And the interquartile range was 24. All right, no scene, 24. Since the median for the first nursery is higher than the median for the second nursery, this means the spread of the heights for the middle 50% of data for nursery 1 is wider than that of nursery 2. Also, you could watch the interquartile ranges, and a higher interquartile range means that the heights are more spread out versus the lower interquartile range. A bag contains 6 red marbles and 5 black marbles. During 2 rounds of a marble game, a student is required to randomly draw 1 marble without replacement for each round. Construct a probability tree diagram to represent this information. All right. So we have at the beginning, picking a marble. So this here is picking a marble. So when I dip my hand in a bag, I can either pick a red marble or I can pick a black marble. So red. When I pick the red marble, remember, during 2 rounds of a marble picking game, so I had to pick again. I pick the red marble. I could either pick now another red or a black. So I can either pick a red or a black. Same thing when I pick a black. As my first pick, I can either pick a red or I can pick a black. Now, what's the probability of picking a red on the first try? I'll go in and put here, let R be the event a red marble is picked. And let B be the event a black marble is picked. So over here, the probability that I pick a red marble is going to be 6 out of 11. I'm rubbing off the colors so we could look at probabilities alone now. Then the probability that I pick a red marble on the second try, I take out the red and I throw it away. Cool? So now I have 5 red and I have 10 marbles in the bag. All right, Manda. The probability that I pick a black, I have 5 black and I have 10 marbles in the bag. The probability that I pick a black on the first try going to be 5 out of 11. Then the probability that I pick a red, I have 6 red, but I have 10 in the bag. And the probability that I pick a black, I now have 4 black with 10 in the bag. All understand the probability tree? Yeah? 4 marks. Using your answer, find the probability that all marbles drawn are the same color. So let me go down the branches and see which times are going to have the same color. So the only times I have the same color is if I pick a red and a red and a black and a black. Yeah? Find the probability that the marbles drawn are all the same color. So let me let X be the event that all marbles drawn are the same color. So the probability of X going to be the probability of red and red plus the probability of black and black, which is equal to the probability of red multiplied by the probability of red plus the probability of black multiplied by the probability of black. The probability of the red on the first try is 6 out of 11, then multiplied by 5 out of 10. 6 out of 11 multiplied by 5 out of 10 plus the probability of a black on the first try is 5 out of 11 multiplied by 4 out of 10. Leave probabilities in terms of a fraction. Don't put probabilities as a decimal. So let me see what this is. 6 out of 11 multiplied by a half. 5 out of 10 is a half. Plus 5 out of 11 multiplied by 4 out of 10. 5 out of 11. All right. Given that 2 events, so A and B, the probability of A union B is 0.7, The probability of A is 0.3. The probability of B complement is 0.6. So I can say the probability of B is 1 minus the probability of B complement, which is 1 minus 0.6, which is equal to 0.4. The probability of A intersect B. Now there's a formula, De Morgan's law. Probability of A union B is the probability of A plus the probability of B minus the probability of A intersect B. A union B is 0.7. The probability of A is 0.3. Probability of B is 0.4. The probability of A intersect B, sorry. So 0.7 is equal to 0.7 minus the probability of A intersect B. Rearrange, I'll get the probability of A intersect B is equal to 0. What relationship between events A and B? A and B are independent events, because if I have an intersection, intersection being equal to 0 means I have no intersection. I can say events A and B. So this is part C, part 1, part 2. Since the probability of A intersect B is equal to 0, A and B are mutually exclusive events, meaning they cannot happen at the same time.